Okay, 8.9, we're doing the disk method revolving around the X or Y axis. Actually, we're finding the volume using the disk method. Okay, we're gonna do it, and as we do it, you'll see what we're actually calculating. So for the disk method, it says sketch the area that is bounded. So for example 1, let's go ahead and do that first, so we can see kind of what we're dealing with. So y equals x squared is, let's 0, 1, 2, 4, something like that. What is that? That's y equals x squared. Okay. Okay, now y equals 0 is the x-axis. X equals 0 is the y-axis, and then x equals 2 is here. Okay, so now what is the area that is bounded? That's going to be this area is the area we're looking at. Okay, now let's look at the next step. The next step says draw the axis of revolution. So we're revolving this around the x-axis. So I'm going to take, this is my x-axis, just keep it in mind. Okay, we're going to take that cross-section and we're going to rotate it around. So it's going to be like looping around like this. It's going to be spinning it around like a rotisserie. Okay, now we're going to imagine we're kind of rotating this thing around, and it's going to be a little bit weird, but we're going to be okay with it. Okay, now if I was rotating this around, okay, I'm going to take this, and it's going to like rotate around like this. Should I draw it? I'm going to try to draw it. Let me see, what is that? 2, 4, 1, 1. Let me look at this little piece right here. Okay, so if I imagine I'm taking this and I'm rotating it around the x-axis, it looks kind of like that. Right here, it rotates, it stays right there. In the middle, it's kind of rotating like this. And all these things are getting rotated around. It kind of looks like not a funnel, but like some weird kind of funnel solid. Okay, we're trying to find the volume of that weird kind of sideways funnel solid. Okay, now let's look at it. Okay, each cross section is perpendicular to the axis of revolution. So a of x equals pi r squared. Okay, I want the volume. So let's set it up. Okay, I'm doing this with respect to x. So in this case, I'm going from 0 until x equals 2. So I'll just start there. Okay, now my cross section is going to be each of these little circles. Okay, since it's rotating, it's a circle. So it's going to be pi. The radius in this case is going to be from here to here, which is going to be the upper function minus the lower function. Okay, so let me go ahead and put the pi. Okay, the upper function is x squared. This is y equals 0, so x squared minus 0 is just x squared. And then this is the radius, and I'm going to square it, and I'm doing this with respect to x. Okay, so that was the next step. It says the volume equals the integral from a to b, so in our case from 0 to 2, pi r of x squared dx, such that rx is the radius in terms of the function, which is here to here. Okay, and that's going to give me that volume of that sideways crazy pyramid thing, cone thing. Okay, let's actually solve this by hand. It's not going to be terrible. Okay, let me rewrite this. This is from 0 to 2. That's pi x to the 4th dx. Okay, so let me raise that degree. That's going to be pi x to the 5th divided by 5, and I'm going to evaluate it from 0 to 2. Okay, if I plug in 2, that's pi times 2 to the 5th is 32. 32 pi over 5 minus 0, which means this is going to be the volume of this solid of revolution rotated around. Okay, that's kind of going through all the steps. Okay, let's go ahead and try another one. Okay, example 2. Take the region bounded by y equals e to the x, y equals 0, x equals 0, and x equals 3. Revolve this region about the x-axis. Okay, I'm going to sketch a picture, although I really don't need to sketch a picture. I think I could do it without it. Okay, so let's see. Y equals e to the x. E to the 0 is 1. And it's going to look something like this. This is y equals e to the x. It's bounded by y equals 0, which is the x-axis, x equals 0, which is here, and then x equals 3, which is somewhere over here, because this is just my sketch. Okay, so this is the bounded area. Okay, and then I'm going to revolve this whole thing about the x-axis. So this thing is looping around here like this. And then I want to find the volume of the new solid. Okay, let me just think about what this is going to look like before I start. Although it doesn't really matter. I could do it without. Okay, remember, I'm taking that whole thing and I'm kind of wrapping it around here. So if I went like this, it would be like something like this. What does this look like? Something like this. The big one's going to look something like this. And then it ends up being this whole like weird shape here. Okay, I'm trying to find the volume of this weird sideways Liberty Bell. I don't know what it is. Okay, anyways, let's do the volume. Okay, I'm doing this with respect to x, so I'm going from 0 to, what is this? What is this line? This line is the x equals 3 line. So I'm going from 0 to 3. Okay, now I want the radius of revolution. So if I went from here to here, that's going to be my radius. So this is going to be pi times, for the radius, the higher function is e to the x. This is y equals 0. So if I do e to the x minus 0, I get e to the x. And then that's pi r squared, and then I'm doing it with respect to x. Okay, then let's go ahead and evaluate the volume of this thing. Okay, am I going to rewrite this? I'm going to rewrite this. 0 to 3 of pi. Let me make this e to the 2x, just to make it a little bit cleaner. Okay, let me go ahead and take the antiderivative. Okay, so pi, the antiderivative of e to the u is e to the u. But because the u has a derivative of 2, instead of timesing by 2, I'm going to divide by 2. Okay, and then I'm going to evaluate this from 0 to 3. Okay, let me go sideways. Okay, I'm going to leave the pi over 2 to the side, just to make it easier on myself. Okay, let me plug in e to the 2 times 3 is 6. And then e to the 2 times 0 is 0. So I'm going to get pi over 2 times e to the 6th minus 1. And I could leave it like this, or I could distribute it out. It doesn't make a difference, but this is the representation of this volume of this weird solid rotated about the x-axis. Okay, let's consider the next one. Okay, last example, it says we're going to use a calculator on this, but we're still going to have to calculate this. Okay, let's do a sketch, okay? Take the region bounded by y equals 4 minus 2x. Okay, the y-intercept's 4 minus 2x, something like that. Let's make it blue. Okay, y equals 0 is the x-axis. X equals 0 is this thing right here. So I'm really looking at this little triangle thing. Revolve this around the y-axis. So here's my y-axis. So this thing's going to get rotated around this thing. Okay, what should we start with? Okay, let's figure this out, because we're going in the y direction. So let me rewrite my equations in terms of y. What is this? This is y equals 0. That doesn't bother me. X equals 0 doesn't bother me either. But that 4 minus 2x, I need to solve it for x. Negative 2x equals y minus 4. X equals negative 1/2 y plus 2. Okay, so this is going to be x equals negative 1/2 y plus 2. Okay, now I want to do the integral. I'm going along the y-axis, so I know it's starting from here and I'm going up to here. Okay, so that's from 0 to, what is this point right here though? Well, how do we get that? We graphed this. So we did 4 because that's the y-intercept. So in this case, it's from 0 to 4, and I can tell just because when I graphed it, I started at the y-intercept of 4. Okay, now I'm going to rotate this thing around. Okay, so it's going around the y-axis, so just imagine it's doing some weird thing like this. Boom, boom. You know, I have like this weird, I don't know what this is. I should stop calling it names. Actually, it's a Christmas tree. Okay, anyways, it's a circle because it's rotating around. So this is going to be pi. Okay, I want r in the y direction. So if I start from the center out, that's going to be this function minus 0. So negative 1/2 y plus 2. And I'm squaring it because it's a circle dy. Okay, this is a calculator active problem, so I'm going to go ahead and put this thing in my calculator. Okay, when I put it in my calculator, I got about 16.755 cubic units. I'll call it units cubed.